Okay, I'm glad to be back here. I think this is my fourth optical communication panel at APSCC. I'm Rizwan Parvez from Lanteris Space Systems, and 10 years ago, I was one of the founding team members for a optical communication startup that, in hindsight, was probably about 10 years before its time. So I come to this conference, I hold this panel so that I can live vicariously through the panelists that are with me today who are continuing the efforts to bring optical communications into our ecosystem to stay. So we'll go down the row here and let our panelists introduce themselves. Stephen first.
Hello. Yeah, so Stephen from Kepler Communications. So I was one of the early employees at Kepler, and back when we started in 2015, 2016, we always thought, okay, optical comms was the correct way to do spacecraft communications, and then, it wasn't the right time, and we came back in 2020, 2021, and looked at it again, and I had the sort of pleasure to say, okay, let's work with the team and see if we can build something here. And so started with the initial system design, and then spent sort of the last year and a half doing our first optical links on orbit, and then onwards and upwards to the operational service in a few months. So happy to hear. Pass it off to Olivier.
Thank you. Good afternoon, everybody. 大家好. Thank you also for Rizwan and APSCC for inviting Cailabs to this panel. It's my first APSCC. I'm really happy to be able to talk about that. So I'm Olivier, VP Sales Laser Communication at Cailabs. What is Cailabs? It's an international company headquartered in France with offices in the US, strong partnerships in Asia, Middle East, and other geographies. What we are doing is we're a ground pure player. In the optical communication, we are building optical ground stations and delivering them to different markets, from observation to SATCOM. Initially LEO, but also other orbits on the roadmap. And what makes us unique is that our team of talented engineers have cracked the turbulence mitigation issue that was kind of limiting the development and deployment of space to ground, while space to space with no atmosphere was more heavily deployed. A few recent news that are interesting to share. So we closed a funding round of about $60 million a few months ago, and that will fuel our industrialization because we are going from the testing phase to single orders of optical ground stations to multiple deployments to ground or satellite operators. And for instance, more recent piece of news, a partnership started with SES a few months ago to start testing optical before putting it into operation. We have a total of more than 10 optical ground stations in production, 2 already delivered, multiple links achieved. We'll talk about this later. And also I'm super happy that the title of the session is Lessons Learned. It doesn't include the words future, prospect, because the optical is here. It's not just the future. It is, of course, but it's also the present.
Good afternoon, everybody. My name is Eric Moltzau, Chief Commercial Officer for Skyloom Global Corp. Thank you very much for hosting this panel and Rizwan for facilitating it for us. Skyloom predominantly focuses on the manufacturing and scalability of LEO, MEO, and GEO terminals, optical terminals, as well as optical ground stations. What makes us pretty unique this year, and we'll talk a little bit about this in the panel, is our ability to be able to scale production at very high volume and deliver on that and deliver on time, and also to drive the technology into the space of long range and high throughput, security, and so forth. And look forward to this panel and talking more about it.
All right, thank you. Stephen, I think we'll start with you. Kind of the first question is, or first comment. This past year, I feel like every quarter, I've seen a breakthrough announcement from your team. You guys, in my opinion, have been way more public about your accomplishments, and I think some of the achievements that the SDA is working for. You guys have been able to demonstrate it and go public with it earlier. So can you go back and kind of recap your year, some of the major milestones that you guys have hit, and then what's coming up in this next year that's bringing you to the edge of your seat?
Yeah, so I'll try to put what we've done in context, right? And so the goal for Kepler is we basically build, you can think of it as optical ground stationed in space. So you fly a Lasercom terminal, and you can point to a Kepler satellite 24/7 anywhere in LEO and get a link, right? And once you have a link, it's basically a long Ethernet cable to the ground. So we've been building towards sort of this vision operational capability for the last 3-4 years. And so, I think Wen last year was on this panel and we had our first space-to-space links for our demonstration system. We came back this year to do space-to-ground links, actually with Olivier's team and Cailabs, and then space-to-air links, so between moving aircraft and a satellite, and that was with General Atomics and the SDA, right? And I think that really, put the bow on the learning and technology demonstration piece for the constellation in terms of, there's all these questions, 2 or 3 years ago in terms of how well will these work? Is interoperability going to work, for example, and all of these sort of things. And so by doing it with the moving aircraft in sort of the most challenging scenario, I think we've sort of shown that, right? So the terminal on the aircraft was a terminal built by General Atomics, and space-to-ground links is way harder than space-to-space. And so that's sort of what we've been doing on the technology demonstration and demonstration side, right? In the background, we have most of the companies working towards the deployment of the operational constellation. So the first operational, that'll be early next year. So that'll be a launch of the operational constellation early next year. And so, the entire company has been busy building satellites, writing software, and at this point, the satellites are built. They're just waiting to be launched. So super excited about that. And then maybe to talk a little bit about sort of the customer commercial traction piece in terms of what we've said. So for example, on the government side, Kepler's prime on the ESA Hydron program. And so ESA Hydron aims to bring the 2.5 gig SDA to 100 gig. And so we're priming that for the LEO part. So that's one example of sort of government use. And then on the commercial side, I think what we've said is Axiom has been using the Kepler constellation, the first operational capability, more or less as a hosted payload. So they want to do some edge compute type demonstrations for their orbital data center product, and so we're helping enable that by flying them basically on their first operational constellation. So you should probably expect more of that in the next year, but yeah, that's sort of what we've been up to.
Okay, thanks. I'll skip Olivier. Eric, so when you look back at your year at Skyloom, what were the major critical milestones you guys hit? I think I read about the delivery of terminals. Are those terminals in the sky yet? And then when do you anticipate those turning on, going through commissioning with your customer? And what does your year ahead look like?
Yeah, so I think a major accomplishment this year for Skyloom was delivering 88 terminals for the SDA Tranche 1 program, for integration on the York spacecraft, York Space Systems. And 42 of those were launched a few months ago. They're currently ongoing checkout. The whole system is, there's a number of payloads on that spacecraft, and not just the terminals themselves. So we're standing by to begin the on-orbit calibration and activities to commence connectivity in space. And so that's the current status. Of those 88 I mentioned, we launched 42 already, or at least SDA did, and we anticipate the remaining to be launched, in the coming months. For us, that accomplishment's a real manufacturing and supply chain proof point. This is just not a vision or an idea anymore. This is optical at scale. And we're pretty proud of that. I think it's a proud moment, not just for us, but for others that are doing the same thing in the industry, to be able to get to a point where we're scaling in large volume. Secondly to that, the other big accomplishment for Skyloom was the standing up of the Skyloom Europe brand. We have a really great partner in Europe, Officina Solari. We have made plans to move out and establishing a production facility in the Veneto region of Italy. It'll double the manufacturing space that we have in the US. And we're very excited about getting that on the road and starting that activity, and this very large accomplishment for us. There's several others, but I'll reserve the floor for some other questions and parties here.
Thanks. Olivier, I think you mentioned just a few minutes ago that there's 10 Cailabs stations around the globe. Are those owned by Cailabs, or do you provide those to other service operators or government operators? Can you describe kind of how is the deployment of these optical ground stations coming about? And then following on to that, you guys have been working, or you're part of the demonstration with Kepler, who I believe has TSAT terminals on your your demo satellites. So you've demonstrated TSAT down to a Cailabs ground station. If those are SDA compatible, does that mean anybody who has an SDA compatible terminal on their spacecraft will be able to connect to a Cailabs design ground station?
So to answer the first part of your question, we haven't delivered yet the 10 ground stations. They're under contract, they're under manufacturing. And we're actually kind of filling up our production capacity for the next 18 months. So any new order will be beyond that. And we're actually, we just built a new production facility to deliver up to 12 per year starting next year, and ramping up to 10s per year in the following 2 years. The customers for these ground stations are different types. Some are space agencies, some are government agencies or MODs, and some are commercial ground station operators or satellite operators. Our goal is not to compete with our customers, so we are not going to become an operator. We don't operate these ground stations, or we don't monetize the passes, basically. This is the role of our customers. That being said, we know that it's new, it's innovative, and we need to help them jumpstart. So we can operate on a need-to-do basis, like initially or for a limited period of time to help jumpstart that. But Cailabs is a very technical company, 160 people with 2/3 engineers and maybe 35 PhDs. We are hardware by heart, and we want to deliver the best hardware possible. To answer the second question, yes, out of these 10-ish ground stations, we already delivered 2. So there's one installed in France, operated by Cailabs on behalf of the French government, and the second one owned by SSC, Swedish Space Corporation in Australia, and both have done links. We've done links with a French constellation, MOD, so no details. We have done links with Norsat TD just before its decommissioning with the SSC station in Australia. And more recently, we've done dozens of links, uplinks and downlinks with the Kepler constellation. So the 2 satellites that have terminals on board, TSAT terminals, SDA Tranche 0 compatible. And it's been a great lesson for many reasons. The first one is, it works. It means these terminals were built for OISL, inter-satellite, but if you point them to the ground, you can do successful and robust links. And we repeated that multiple times over very low elevation angles, from low elevation to low elevation, over different types of skies, even light cloud, light fog, this type of things. So that was great learnings. And second, we also discovered that the SDA standard can be upgraded or optimized for space to ground. We made some recommendations through some MOSA meetings, for instance, on how to make these even more efficient for ground without any hardware change. So everything that's already flying can remain the same, and some software upgrades can even make it better, but it works even without that. And we'll continue, and not only Kepler, we're open to any, we're agnostic, so we can work with any constellation.
Okay, thank you. Eric, you mentioned earlier, or in past activities, you guys have a GEO project, you're very heavily involved in LEO now. Are you guys also looking at MEO? And as you kind of just look across all those three major orbit domains, where are you guys finding yourselves putting the most attention to? LEO's clearly adopting it now with some of the proliferated LEOs. How do you see the future for MEO spacecraft adoption, GEO spacecraft adoption for these optical terminals?
Yeah, that's a very good question, because a lot of the focus early on, right, has been on LEO. We're seeing a substantial upswing in demand in the MEO market as well as GEO, and it's not just government; it's also commercial. We do have a contract now with a government customer to build out a MEO terminal. Some of that's been extending to some commercial customers as well. They're showing demand. I really think that this build out of infrastructure of, LEO, MEO, GEO ground, it really is building up to, kind of what we enjoy here on Earth with terrestrial connectivity, and what the engineering did, decades ago, to get us to what we have today by having, the ability to be able to have switch routing and so forth, to be able to move traffic. And I think that is something well in our future, in our grasp in the near term, to see that, with mesh networking in space and so forth, and taking advantage of all orbital regimes, because LEO's great, but it's got some drawbacks that GEO brings in, and then GEO's got some drawbacks that LEO brings in, and MEO as well. So I think the ability to tie all those orbit regimes with the ground on will give ubiquitous connectivity that we're all looking for the data and communication markets.
Thank you. Stephen, so all of these space business conferences that I've been to in the last 5 years have had so much focus on how the telecommunication providers and launch vehicle providers and how their strategies have had to be revisited and adapt to SpaceX and Starlink. This past year, we've been reading about the potential that in the US government, Starshield may supplant the SDA transport layer. We've seen that they're offering their Blazers that companies can buy, install in their spacecraft, and utilize the Starlink as a data relay system. So in this ecosystem, SpaceX and Starlink seems to be coming into the data relay world. How does Kepler stay differentiated? What are you guys doing to watch out for and hold back the potential of a very large organization dominating your field?
Yeah, I think this is a question of sort of fundamental philosophy, and if you're building critical infrastructure in space, and I'd certainly classify the satellites we have and spacecraft communications as critical infrastructure, right? And whether you want to build that on a closed standard or an open standard, and whether you can afford to have a single point of failure, whether that's a single country or a single company, that covers the entire ecosystem. So SpaceX has their own terminals, their own spacecraft, their own ground segment, right, in a single country. So you can imagine that for a sovereign constellation, like that's simply unacceptable, right? And so I think that's sort of the main philosophical difference that we carry, where we're focused on having an open standard that we build towards, right? And you can see parallels sort of everywhere else in terrestrial communications, right? Like to Eric's point, the future of spacecraft communication should look like terrestrial communications. So cellular standards, for example, right? So the reason the entire cellular industry works is the reason the ecosystem is so large and it can be used in every country around the world is you have a common standard in 3GPP. So that's 4G, 5G, whatever, right? And once you have that standard, you can have an ecosystem of optical terminal makers that all build the same thing, and optical ground stations that all work together and data relay providers like Kepler, right, that all work together. So, I mean, really, you should have a single physical layer standard that the entire world builds towards. And then, okay, there will be individual companies building ground stations and satellites and whatever, but I think that's the only way you can have real scalable, sustainable use for Lasercom. If you have a single company for especially some of these sovereign missions and some of the requirements we see, like it's not going to be a scalable, sustainable way you could do it, right? Like from a global perspective.
Thank you. Olivier, so optical clearly has huge bandwidth advantages, but certainly when I was studying optical ground stations and trying to figure out the needs for cloud-free coverage locations, high and dry places, it often meant that those locations had terrible ground infrastructure, no backhaul connectivity, and it kind of made the ecosystem a bit challenging to put together, right? You get a whole bunch of data down to the ground, but no efficient way to get that data back to locations that want to use that data. So your company's technology has been focusing a lot on atmospheric mitigations. How far is this going to go into being able to place optical ground stations in locations that have infrastructure to be able to fully utilize the amount of data that optical enables?
Yeah, that's a great question. If you look at the best locations to put an optical ground station, it's clearly not the same as where we would put astronomy observatories or antennas for different reasons. Observatories are put in the middle of deserts or top of mountains or on islands where there's very weak connectivity to the main network. So the holy grail would be to manage to put these as close as possible to infrastructure, data centers, and so on. To do this, you need to go from, let's say, a test ground station to an operational one. And to do this, you need there are several technical challenges to break, and one of them is linked to the atmospheric turbulence. So that's the Cailabs technology part, where we don't use adaptive optics, but something scalable and robust. And there are other things. There's also the holding budget to consider, including the size of telescope. So we know like very smallish ground stations will not be able to be put everywhere. So you will need some kind of critical size to allow this mass deployment close to data centers. And then there's the question of routing the data to the right place at the right moment, avoiding clouds. So we're talking about spatial diversity, and this is where we need some kind of meshed network, hybrid, that would include not only ground, but data relay, OISLs, where the whole network will be able to route the data from the customer to the right point. I think I've heard in a previous conference discussed with some EO companies that said that told us the response time, I mean the latency to get data from EO acquisition to the end customer is critical. If they don't deliver within 15-30 minutes or whatever the SLA says, they don't get paid. So you cannot say, oh, a cloud was there, or oh, there was turbulence. No, you need to have something robust that guarantees this SLA, and this is done at the ground station level by using robust technology and at the network architecture level.
Okay, thank you. And just a real quick thing I read the other day about a company that has this idea of pulsing an extraordinarily high power laser to punch through clouds and then following that up with a data laser. Any comments about, is that feasible? Is that real? Are birds going to burn up as we go through the atmosphere? Like, how's that going to work?
I've read about this. So to answer this, I will put my other hat and rebut my optical engineering background 20 years ago. And I have good friends working on this very topic of filamentation of lasers through clouds. So it works if you send tremendous amounts of power. And basically the technology today is able to pinch holes of a few centimeters or tens of centimeters. So, and this is completely not eye safe, not bird safe, not plane safe, and probably not satellite safe either. So on the technology level, it's super interesting to watch, but it's Star Wars level at the moment.
Okay, thank you. And a question from Peter for you, Eric. Does the structure of setting up your European operations allow you to go partake in the European government programs we've been hearing so much about in the news?
That's a very good question. One of the reasons why we drove the Skyloom Europe brand is we're seeing this huge demand upsurge in Europe, for optical links, driven by needs for security, high data rates, and higher data rates and so forth. So yes, the answer to that, and we are actively working with a number of different customers. Our team in Europe is, our Officina Stellare partner, to bring, our technology to those programs with the production of product, variety of our different terminals. As I mentioned, LEO, MEO, GEO in the Europe Production Center. So those would be made in Europe.
Thank you. And that wraps it up for this panel. I want to thank our panelists for joining me here again this year. And back to Andy.